Hi, thank you everyone for joining. I hope I'm audible. Yeah, yeah, thanks for the confirmation. So, yeah, so let's just start without further delay. Yeah, so I thought of going over the week 1 and week 2 assignment solutions. And if you have any doubts regarding those, uh, please, you know, stop in between when we are trying to discuss this, and then we can go ahead. So, yeah, how do you want to go over these solutions? Like, do you want I think you might have already known the answers for these. So, are or do you want to answer them as we go ahead, or should I just go on and try to answer them myself? Okay, then I will go slightly, you know, answering it myself and then try to discuss the solution if there is anything to discuss there. Or if, yeah. So, yeah, scarcity of food is a whether it's a chemical factor, demographic factor, push factor, or pull factor. So, with respect to distribution of species, what it could be. So, it generally is a push factor. Basically, it pushes the species to certain areas versus, uh, exclude the species from certain areas. So that's why it's kind of acts as a push factor. Food, especially. And the second question: the geographical discipline of climatology is most closely related to geology, meteorology, hydrology, and pedology. So, climatology is basically trying to understand the climate in terms of a very longer time span, right? So, here the one that actually is related to climate is meteorology, but meteorology uh, is it also deals with climate, but in a very shorter time span, right? If you remember from news recently, the Indian Meteorological Department that is supposed to the whose job is to predict, you know, weather patterns across the country. So that is the short term climate. While geology is the study of time, scales are basically the earth, hydrology is the water. Yeah, and yeah. So yeah, going ahead, the Trinity explosion of 1945 is taken as the beginning of the Holocene, Canocene, Anthropocene, Eocene. So, if you remember, during the last during the first week discussion we are discussing about different eras. So how we put events in with respect to time, right? How so we have been naming things accordingly, and then one such is the Anthropocene. Anthropocene is where the human influence has actually started, the era. So the Trinity explosion has been used as a cutoff to say, this is when the impact of humans on the earth has taken a significant turn, and then that's from when you can call, as a different era called Anthropocene. And this is little straightforward question. The word root for conservation, the con stands for together, and survey stands for to keep. So both of them were there. Yeah, to keep. So this is a little straightforward one. Going ahead. So good climate is a. So earlier we discussed about food being a push factor because it kind of pushes organisms towards certain areas or pushes away organisms from certain areas of where there is no food. In similarly here, good climate is a pull factor. Basically, if there is a good climate in terms of what an organism requires, it kind of draws the organisms towards that area. So in that aspect, in that way, good climate acts as a pull factor, pulling organisms into that area. Similarly, uh, the rate of any biological process is limited by the factor in least amount relative to requirement. So there is a single limiting factor. So this is the statement for which law. So it says that there are a lot of factors that are essential for a biological process to ensure, but there is one factor that is present in the least amount that acts as a single limiting factor for the whole biological process. So this is the definition of. This is also called as Liebig's law of minimum. So where the lowest uh, factor limits the rate of the biological process. So the discipline of demography is most closely related to. So when you say demography of a species, you mostly talk about the population geography of the species, how the populations in an area, how they are surviving or any other things with respect to the population of a species. You use the term demography. While zoogeography and phytogeography is the study of plants across a larger geographic area, basically distribution. Similarly, zoo is for animals. So here is another definition for uh, allowing some places and some creatures to exist without significant human interference. Is the definition of what? So here you are not allowing any without significant human interference. So you call it preservation. While in conservation, you tend to have some sort of human interference to allow things to, you know, be there. So the last question for week one was the movement of lions across Gir landscape is an example of what? What type of dispersal? Whether it's a diffusion, secular dispersal, jump dispersal, or drifting. So it's diffusion. Basically, the lines in the landscape kind of, slightly, uh, they're slowly spreading across from the landscape and outside the Gir landscapes, as if they're slowly moving outside. Kind of in similar fashion to diffusion, how it occurs. Okay, uh, Sriharini, this is from which set of lectures? Is it week 4 or week 3? Because I don't think it's week 3. I think it should be week 4. Week 4, right? Then I will try to touch upon that in the next Monday. Hope that's okay. Because this week I'm trying to cover the topics from week 3. Hope that is okay. So next week when we start, I'll try to start with this question, this concept, which, yes, chalo. Yeah. So That's for the week one. And then coming to week two, uh, so this question is with respect to the transmission of earthquake, so the propagation of earthquake. So there are P waves and there are S waves, right? So which of this is true about P waves? So these are longitudinal waves or these are transverse waves. Longitudinal, they just follow around the same level, or they just come up to the surface, or they cannot move through gases, they cannot move through liquids. So P waves are kind of, uh, just uh, longitudinal waves. So they just travel like this from the source of the wave, source of the earthquake, right? So those are P waves. Inclusions are older than the host rock. This is known as. So inclusions are anything that kind of occurs within any material. Here it is within a rock. So when inclusions are when inclusions that are present in a rock are much more older than the rock, then they are called, it is known as principle of inclusions. And then Mount Fuji is an example of. So if you remember the different type of volcanoes that we are talking about, based on the crater and then type of flow it has, Mount Fuji is an example of a stratovolcano where you have a dome rising above, right? And layers of rocks deposited from above, examples such as sediments and lava flows, are originally laid down horizontally. This is known as principle of original horizontality. So which of this is not a method of absolute dating? Radioisotope dating, thermoluminescence dating, inclusion study, fission track dating. So we have two types of dating, right? Absolute versus relative. Relative, you compare it with something else, while in absolute you just use that to say what is there is no other standard to compare it with. So inclusion study. So while in radioisotope dating, if you remember, we try to understand the decay of certain atoms of certain radioisotopes to understand what could be the age of this. While in absolute dating, you don't do that. Yeah. Uh, which of these is true about S waves? So earlier we spoke about P waves, and then this is S waves. So these are transverse in nature. So okay. So if this is the origin of earthquake, they kind of propagate upwards to the surface from the point of origin. Which of these is an example of direct source of information about Earth? Earthquake, volcanic eruption, magnetic survey, gravity anomaly. So volcanic eruptions are a direct source of information about Earth. Similarly, assemblage of fossils are unique to the time that they lived in, and so can be used to age rocks across a wide geographical distribution. This is known as. So we know that there are set of fossils that are unique to the time that live in. Like for instance, if you find dinosaur fossils, most of the dinosaur fossils are from the age where they have been predominant, which we call as Jurassic era, let's say. And it can be used to age rocks across a wide distribution. So if you know rocks that have been found along with these dinosaurs, you know these are also from the same era, right? So this kind of aging date or dating, this is also known as principle of fossil succession, because you are using fossils information to try to age rocks here. And within a depositional basin, strata are laterally continuous in all directions till the edge basin. This is known as. lateral continuity. So yeah, the Krakatoa eruptions resulted in the formation of uh, it resulted in the formation of caldera. Uh, yeah, I think it will be. I forgot to add a picture of this thing, but it will be interesting if you can go and check out what these eruptions were and then how it resulted in the formation of caldera. Yeah, so that's all for the uh, assignment questions for week 1 and week 2. So if you have any questions regarding week 3, I would take week 3 lectures. I will take them and then try to discuss them now, or else we'll start in a while. Yeah, the the topic, the tropical and subtropical cyclones, I will try to discuss in the next lecture, next session, which happens on Monday. My next session is next Monday. So yeah. So yeah. So let's go ahead and talk about some landforms that we see on Earth, right? Uh, the previous week we have seen that the Earth has so and so layers, and then we have what we call crust. There is mantle and then there is core, right? And then the top part of the crust, basically top layer, plus the upper solid, most of the solid mantle, is what we call as the lithosphere. Lithos meaning rock, sphere. Uh, yeah, not exactly sure. Can someone say what is the word sphere means? Okay. Uh, okay. Sphere is. Uh, any guesses? Anybody? The lithos stands for rocks. Sphere is. Yeah, it's just sphere. Okay. Similarly, the next sphere we have is of atmosphere, right? This is what we know from, from what we have been studying as kids, most of this. And then this is what we call, the outer layer of the earth, which has the air and other components of it. And this atmosphere is further divided into further spheres like troposphere, stratosphere, mesosphere, thermosphere, exosphere, depending on the height and the constituents of different gases that are present in it. Right. For instance, the ozone layer, which is an important layer, important structure, part of the atmosphere that helps us that protects us from UV radiation, is present in the stratosphere, right? And most of the the commercial airliners also fly in the troposphere and stratosphere. And then the beautiful auroras that we have, watched in TVs or photographs, most of them form in the thermosphere, and then the exosphere is the outermost layer of the atmosphere. And the temperatures of these different layers also with the temperatures of these things. And most of the lithosphere actually ends in the troposphere. Basically most of the mountains, they extend most of until the troposphere. The Mount Everest, which is 8.8 kilometers or something above that, yeah, so above which the troposphere kind of ends. And then the other thing is the hydrosphere. So hydro means water, the sphere. So the part that talks about water is the hydrosphere. And then if you remember, most of the water we know we have on Earth is in oceans, freshwater, rivers and lakes, and then most of the fresh water is in the form of glaciers and ice sheets, right? And then we have water that is present within the living organisms itself, right? And then there is this thing called, along with water vapor, we have most of the water in the northern latitudes as permafrost. So permafrost is nothing but it's frozen soil. So it and then it has been frozen for very long period of time, and then it stays frozen. And then it the other thing about permafrost is because of climate change and all, because of the heating, warming of the earth. So most of the northern latitudes, the average temperature is also rising, and then this leads to thawing of permafrost. But since permafrost with itself holds a lot of carbon, and then it has frozen solid, uh, so if the permafrost kind of melts, it's kind of detrimental to the carbon cycle, because most of the carbon that has been frozen, that can't be used by most of the organisms, is open to use, and then this will kind of exacerbate the effects of uh, climate warming that we are going to witness in the coming years. So that's why permafrost also is an important source of water across earth. And together, all of these three together put together constitute the biosphere. And along with the along with the living organisms, it it is the biosphere. Yeah. So let's talk about rock versus minerals. So what's the difference between a rock and a mineral? These are some representative images, but yeah, please type your answer in the chat box if you know it, or you can unmute yourself and then you can answer it. Rock versus mineral. Guesses? Anybody? What's the difference between a rock and a mineral? Okay. It seems nobody is answering. So I'll slightly go ahead. Minerals are made up of specific elements, while rocks contain two or three elements. Yes. Yeah. Right. So let's just go over it again. So, rock is a collection of minerals. They are generally made up of two or more minerals, right? And then these minerals are kind of mixed through geological processes, and then this results in the formation of rocks, right? For instance, one such example uh, is granite, right? Most of us have have one-to-one experience with granite, either in form of the slabs that we have might have seen on tables, be it from working place to hotels or restaurants. This is one such rock that is formed of multiple minerals, right? While minerals is a naturally occurring substance which has its own signature in terms of its chemical properties, its physical properties, its composition and atomic structure. So while in rocks the composition of minerals might vary, but in mineral the composition is kind of fixed. So it doesn't vary. So for instance, this is a mineral called calcintite, right? Yeah. And yeah, going ahead, uh, we, types of rocks, right? There are multiple types of rocks based on in terms that have been classified based on their formation types. Uh, does anybody can put up some guesses of what are the different types of rocks based on their origin? Yes, igneous, sedimentary, and metamorphic rocks. Uh, yeah, so igneous, sedimentary, and metamorphic rocks. So if yeah, igneous rocks are basically formed post volcanic activity, right? Uh, while the continuous accumulation of sediments post transport, mostly through water or other forms, results in the formation of sedimentary rocks, right? And the metamorphic rocks are a different case where the rock itself has transformed. Metamorphosis, if you remember the term, that is generally used for commonly used for moths and butterflies, where the larvae transpupates and the pupa comes out into a adult butterfly. So it has transformed. So here the metamorphic rocks are the rocks that are transformed itself due to various geological processes, right? So yeah, sedimentary rocks, they looks pretty cool, the sedimentary rock, because of the way the sediments have been uh, you know because of the formation of the rocks and the way sediments have been kept on accumulating, and then because of the action of erosion, that also these sedimentary rocks and these rock formations also, they look so beautiful just to witness. And then these igneous rocks, you know this is a rock that is generally formed immediately post volcanic activity, the one that is being shown in the picture. While the granite is another form of igneous rock where uh, it is formed under the surface itself. It hasn't come out onto the surface, where you know deep inside uh, the earth, because of the pressure, it 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 ends up becoming granite. It has this gross crystalline texture, while the igneous rocks such as the basalt has very fine crystalline texture. And then the metamorphic rock examples could be marble or slate, while sedimentary rocks are sandstone and limestone. Yeah, this is another and this is the cycle. So this is also called as rock cycle because there is a possibility of interconversion of one rock into another. Like for instance, let's start from magma, because it's what, when it cooled, leads to formation of most of the rocks, right? So when magma cools down, it leads to the formation of igneous rocks, and it can again, post melting, it can become again magma, right? But when the igneous rocks are exposed to weathering, and they are eroded by constant wind or water or action of any other element, they form what we call as sediments, right? And then when these sediments keep on accumulating on top of each other for a longer period of time, that leads to the formation of sedimentary rocks, because these rocks have been accumulating, and then there is a strong compacting that has been going on these rocks. And then when if these rocks are weathered again, it will lead to the formation of sediment. But if not, when there's a subductions that happen either because of earthquakes or any other reasons, these sedimentary rocks, when they go inside the further inside the earth because of the subduction, they are, for subjected to high, very, huge amount of heats and pressure, and then they metamorphosize into metamorphic rocks. Similarly, igneous rocks also can metamorphosize to metamorphic rocks when they're subject to heat and pressure. And then if it's melted again, it will again become magma, or it can erode and become sediments also. So most of these rocks have originate from magma, but they also more or less end up with that magma. So this is called as rock cycle. Just if you can remember it. And then since we're talking about sediments, uh, yeah, this happens due to this phenomena called weathering. Uh, can someone say what do you think? What comes to your mind when you think of this term weathering? Yes. Yeah. Yeah. It's in simple terms. It can be a simple breakdown of rocks, mostly rocks, right? Uh, can you can you think of some agents that are the reason for weathering, that are the causes of weathering? Okay. Yeah. So there are different agents that can cause weathering. So mechanical, it can be just, a rubbing of two rocks, right? That can be an example of mechanical. While wind and air, sorry, so wind and water are one of the major uh, agents of weathering, right? And even biological factors like uh, can play in weathering. And like, for instance, some organisms do create uh, some sort of chemicals, right? Some sort of enzymes that can actually lead to breaking of these soils. Like, if you remember, in terms of biological succession, initially rocks are colonized by lichens. When these lichens are actually growing up, uh, they also release some sort of enzymes, so that might actually further weather these rocks or lead to breakdown of some of the rocks. If not the whole rocks, but the top layer, that can lead to breaking. So there are number of ways it can happen. And then this is an important for you know process in the formation of soil. So weathering is what leads to the formation of soil in the later term. And then there are these geomorphic agents that do the weathering, but they also they kind of remove, transport, and deposit earth elements from one place to another. Like, for instance, we have water, wind, waves, glaciers, ocean currents. So let's talk about the example of water, right? Uh, if you are if you have visited most of the Himalayan region in India, or even in the Western Ghats, where you have these huge rivers that, in the monsoon, they become so turbid because they are carrying a lot of silt with them, right? And then this silt they are removing, because from the post rain the silt is removed. They're transporting across a wide geographical region, and then they're depositing somewhere else. For instance, you talk about the river Ganga, or that originates in Uttarakhand, Gomukh, right? Once after it originates, it is heavily filled with silt. Once it reaches Rishikesh, the river kind of actually widens because of, you know, multiple tributaries kind of joining in by that time. But as it reaches further UP, the Gangetic plains, so it kind of, that's where it actually deposits the remaining remainder or the most of the silt it carries, and then it kinds of becomes clearer in the regions. So, and similarly, wind, waves, glaciers are also a major source of, you know, geomorphic agents, and then ocean currents. Uh, Ocean currents are one of the primary geomorphic agents, not in just in terms of, moving uh, the soil, but they are also helps in circulating the nutrients within the oceans, because yeah, they, because that's how things get recycled in the oceans, and then a lot of these organisms that are bottom dwellers get to feed themselves. And then some of these oceanic currents are exported by organisms that migrate to, for travel, for migrating across different regions. Erosional landforms. So these are landforms that are formed post the erosion, right? Uh, for instance, what do you think of this picture that is being shown? What could be the reason of this form? How do you think this landform was formed? Like which agent could was responsible for this landform? Sorry, sewage. Uh, Someone said water. Yeah, it's water. Basically, it's a flow of river that has resulted in this formation. See, the one thing that you can try to look out and try to guess is, when water kinds of erodes a land, a landform, or results in the formation of landform, it kinds of smoothens the surface out. If it has enough time to act, it will smoothen the surface out. Like if you have seen most of the pebbles in the rivers or streams, they are kind of rounded, right, because of continuous action of water, and then immediate collision of with other rocks also, but there is a action of water that happens. So yeah, so there are different landforms that are actually formed by the action of water. One that was discussed, in depth, was in the lectures, was the canyons, right? Canyons and valleys. So in India also we have some canyons. The famous canyon is the Grand Canyon in US, because it's so huge, and then it is so deep, and then it's just mesmerizing to watch the Colorado River going across the canyon, and it's also so deep, right? Similarly, there are multiple canyons in India also. Maybe you guys can check them out. Yeah, later on. But these are caused majorly due to deposition of, sorry, continuous action of water across millions of years, right? And sandbars. Can someone guess how are these sandbars formed? Ocean currents, yes. You're right. So what happens is, uh, these ocean currents, when they are moving around or due to the continuous action of waves, the sand that is actually kind of washed away from the shore kind of gets deposited in regions with low versus uh, little slightly higher regions in the ocean. So it's not an even ground, right? The ocean is not an even, it's not even, it's kind of uneven. So some most of the times this, so when the waves kind of go back after hitting the shore, they take away some of the sand that is there on the beach, right? When they are going backwards, so that they actually tend to they will deposit it once the force of the wave kind of decreases. So most of this deposition happens around the areas where there is slight uh, you know uh, increase in height of increase in the depth of the ocean floor, where it's not that deep, so the ocean current kinds of pushes all the sand towards that area, and then it keeps on accumulating, and then it leads to the formation of these beautiful structures, sandbars, right? And then some of the sandbars might uh, get submerged during high tide if they are too close to the shore. Some of them might not be. So yeah. So and then most of the time they can be connected to the mainland, or they can be just floating around in the middle of the ocean. And then there is this thing called spit. So this is also by this is also formed due to the action of ocean currents, right? uh, this is basically the extension of the beach, as if you can see from the image here. uh, it is basically an extension of the beach, but due to the movement of wind, it can slightly curve up, but there is no landform as such. It's just the deposition of sand, and then just extends deep into the ocean. See, if you can see from here, it's all white, which is basically says that most of it is just sand, and this is where much of the deeper end of the ocean begins. And then because if there is a strong wind currents, this the spit the tip of the spit can kind of curve, and then have some sort of this curvy end, all just because of ocean currents. And then another prominent geomorphic feature or geomorphic agent is the wind, right? And that results in the formation of or the shift of sand dunes. The mechanism how it kind of moves has been explained in the class if you remember watching it. So basically what happens is as the wind goes on, it just kinds of takes the sand from the bottom and then keeps on depositing it onto the top, and then the top kind of shifts slightly to the right because the sand from the top actually goes down to to the further side, and then that results in shifting dunes. And then because of wind this happens predominantly. And then the other thing is glacial moraines. So this is the action of resulting action of glaciers. Sorry. Yeah. So glaciers, these are thick blocks of frozen water or basically ice that have been accumulated because across for multiple years, right? And then when these glaciers kind of goes around or retreats, or when these are present itself, there are these landform structures mostly made up of the glacial till, which comprise mostly of sand, the basically the soil, and then lot of rocks also, results in the formation of these structures called moraines, right? And then if this moraine is present at the end of the glacier, basically where the glacier is ending and then the river is starting, so you call that end moraines. And there are different terms for different lengths of moraines. And while if there is a moraine that is present that splits the glacier into two in the center, it's called medial moraine. While the edges of these moraines are called as lateral moraines. And yeah, this is how it can look like. So this is the terminal end of the glacier, and this is the this is the sorry, yeah, this is the end moraine, and these are the lateral moraines that you see on the edges of the glaciers. Right. Yeah. So yes, that's all I had for today. So if you have anything related to these topics, I would be happy to discuss with you guys. Yeah, this is how basalt looks like. So anybody has any questions or any? Okay. So I will wait here for five five 5 to 10 minutes to see if anybody has any more questions I can so that I can answer. Yeah. If not, yeah, yeah, sure. Go ahead. Sedimentary rocks can directly become igneous rocks. Is that the question? No, because igneous rocks are formed post the cooling of the magma, right? So the source of the igneous rock is the magma. So if it cools down outside, you will have some sort of rock, igneous rock. If it cools within the under the surface, you have other type of igneous rock. But sedimentary rocks can metamorphosize and form into metamorphic rocks. But for it to form igneous rock, it has to again melt and become magma. Then only it can become igneous rock. Hope that was okay. Could you understand? Yeah. Or just or yeah, or you can just have a look at this picture also, because it has to melt it even if, without heat, without metamorphosizing also, it has to melt, it has to form magma to become igneous rock, because the source of igneous rock is through magma, cooling of magma. Okay. Yeah. And yeah, since you're discussing about rocks versus minerals, there are certain minerals that are kind of building elements for there are some set of minerals that are major contributors to the building up of uh, most of the rocks that we see. Either granite has some sort of X and Y, but I'm not sure which what all the minerals that are present in granite. But there are this set of minerals that are predominantly found in most of the rocks that we see, because they are one of the commonest ones. Like hematite is one of that mineral which is mostly found in hematite. Heme is basically iron, so mostly found in rocks that have like iron ores or rocks that have these associated with them. Yeah. Yeah, I think that's all I have. Uh, if you guys have any more questions, I will wait for a while and then I'll try to answer them. If not, that should be the end of the session. Or if you have any topics that you want me to talk about in the next session, I would be happy to, you know, take notes of that and then try to discuss them in the next session. Okay, then we'll stop the session here today. Thank you for joining.